Welcome back to my channel. Let's continue with another episode of microservice with Node.js. In this episode, we will discuss how we can segregate read and write responsibilities of the microservices over a distributed database. So far, we have achieved the interaction of the microservices through message broker. As you can see here in this diagram, we have introduced message broker and we are trying to communicate with other services with the help of the publisher and the subscriber by subscribing and publishing certain events where the channel, exchange, and binding topics are going to be work together. So far, everything is going good. And finally, we have deployed our services on AWS, right? All right, so we are going to cover this continuous deployment setup and trunk-based delivery and all right after this episode. Perfect. So now, what is next? In the next level, we're going to cover these other points. So what are these points are exactly? So first one, we will segregate some of the responsibilities of our microservices to follow pure secure pattern. And number two, we will optimize our services so we can make it scalable. So secondly, we will optimize our services to make it scalable. So I have received a couple of questions regarding make it scalable. So definitely we will get an answer in upcoming episodes how we can make it scalable. Here you can see we have deployed our services as a kind of Docker container and we're keeping the provision of make it scalable also. So certainly we'll cover this topic in upcoming episodes. And third one, we will refactor our code base to keep the meaningful data close to the services. Because right now you can see we have in our services, every service have their own data, but some of the data which is exactly it's not related to the specific service, or maybe we are just keeping with it just to make sure that specific job can be done by that service. All right. So that was a kind of intentionally I'm just keeping that one because in the very first day of the microservices tutorial, if I'm going to deep inside the complex topic or make it in complex way, then you people who are exactly starting to learn the microservices ecosystem, and then definitely they'll find a kind of puzzle, or maybe it's a complex topic, right? So to make it easy, I just kept that way. That is the thing exactly we need to do little bit refactor, right? And fourth one, we will just revoke redundant data from the services. As I told you, this refactor maybe it will cover partially of the fourth point as well as restructure our models. So that is the part we will cover in the fourth point. In the last point, we will isolate our DB instance with a special access to perform DB operations. So right now here you can see the database instance also, the database container also, we are just spin up together with the same AWS instance, right? So if something is going to be happen right here, so there is a chances of losing the data, right? So the services that's not a problem at all because we can just reinstantiate all the services, then again it will come back. But in terms of like database, there is a kind of complexity here. Okay, so to get rid of this complexity and the problem, then we can segregate our database to a dedicated AWS instance. So inside that instance, we will just run our database container or database operations, whatever right there it is. And the another AWS instance, which is we are just to spin up right here. So this instance will be spin up all the services, and the body instance will be connected through the private access. In terms of we are going to place the body instance in the same VPC. So in this database instance, we'll assign the two security group. One is for accessing the data from the microservices. All right, and another one is a kind of bastion security group that is going to be will expose a kind of bastion host, so we can access our DB instance from our local machine with the help of opening a tunnel or with the help of SSO profile. So these are the things exactly we are going to do in the fifth point. We will work on this first point. So how we can segregate the responsibilities. That is we will look into. So let's simplify the interactions. Currently, what's going on? So right now we have three services, right? So all these services are communicating through message broker, where they're just publishing and subscribing some events and doing the operations. So we are going to introduce RPC. So with the help of RPC, we are segregating the read and write operations, right? So right now the write is happening through subscribe and publisher pattern, where we are just firing kind of event and providing kind of payload, and we are not looking back, like we are not looking for a response. exactly if that specific service is listening, then it is just subscribing and it is just performing some operations and inserting data to its database, right? So which is exactly leads to redundant data for each DB, right? Someone asked us some question like why we have redundant data right here, and because we just kept the redundant data intentionally, because if I'm going to explain everything in the first page of the microservices introduction, then definitely those people who were exactly just jumping on the microservices and try to learn from the beginning, they will find it complex, right? So I'm just trying to make it simple first, and then we'll just refactor and restructure it. So that is the way you can understand the mechanism and you can have a clear picture, right? Here in the customer service, we are having all the customer data along with some of the other redundant data in terms of product ID, description, price, and other stuff, which is exactly residing right here in the product as well as. And while we are dealing with the shopping, and it is residing right here in the shopping DB as well as. So to get rid of all the stuff, with the help of RPC, that can be possible to resolve it. So that's why what we are going to do, while we're writing the data, we will write the specific data, whatever it's needed to specific service. And while we will just reading the data, we will not reading the whole content from here. We'll just keep a kind of specific product or specific shopping reference right here in each DB, right? That means while the customer will add a product, then we will keep the product reference right here. And whenever that specific product details is needed, then we will call the product service with the help of RPC. And hey, this is the product exactly, I need the whole information. So that means if you're going to update the specific product information or price or description, then we will be having always the updated information right here. We don't have redundant data at all. Only we will just keep the product reference, or we'll just keep the reference of other database. Eventually, these are the three distributed data, and we are dealing with all the three data database, all right, with the help of RPC. All right. So each microservice is responsible to give the certain data what exactly other services are looking for. So in the existing source code, already we have introduced this write channel. All right. Into read channel, I'm going to create a kind of fresh project. All right, where only I will just show you how exactly RPC is going to work accordingly. And after that, once that is done, we'll implement the same thing with our existing source code, right? Then we will deploy once again in here in AWS, but this time we will not deploy directly with the help of uploading some zip file. We will deploy with the help of continuous deployment. That is going to be happen in the next episode. All right, then let's jump into the RPC one, create a kind of simple project here. All right, so this is our package.json file. It's created. What I'm gonna do, I'm going to install a couple of dependencies. In your case, you can also use whatever the package manager you like. In my case, I'm gonna use Yarn. And all right, so these are the packages exactly we need right here to spin up this project. And here inside the project, I'm just gonna create a kind of directory. This is called source. I'm gonna create the two files right here. One is called let's say customer.js, and another one is like product. Okay, so these are the two different services. We are assuming like these are two different services, right? And we are creating one more file that's called RPC. Yes. All right. So now what we will going to do, we will just put a little bit boilerplate code right here. Okay. Okay, so I need FM not this report, this is like report and that's like customer run on and put like on that's very fine. It's like this. Put this in, put more report, and yeah, yes. After that, console.clear. Clear. So I don't want to keep the logs just for a long time. Every time we just need to manually clear the log, right? So the same thing we're just going to like use in the product as well as, but here it is going to be product, right? Products, and this is going to be product service. Product service is running on the port, but here in terms of like 9,000, we are just keeping it 8,000, right? So body services is just a kind of simple script, right? We're just spinning up two different Express app, and we will try to run together, right? So in order to run together, we need to set up a little bit in the package.json file here, right? So here what you can do in order to do so, we have already installed a kind of third-party package which is called concurrently, and this is going to help us to run the whole project in customer and product together, right? So let's add some code right here. Also, or you can do like customer and move on in RPC, right? And this is what you do also, and this is what you do, right? And so here, right. That's and here, sorry, and we'll put it right here. I'll this one right and that's it. And so and here, let's put it right here, run, or you can put run, server, and here let's see, and let's see then, and then the thing you put let's here this one, and here, run. This is not like this customer, and right. Okay. So that's all. So now let's try yarn start. Now you can see body servers are running perfectly, right? So now this is the time exactly we are going to add the RPC code right here. Okay, that's cool. Perfect. So add some code right here in this RPC file, right? So let me add the code, and after that I will make you understand what exactly is going on right here. And here we go to before as you All right, so what we are going to do here, this is the connection exactly we are going to reuse throughout of our operation. So first of all, we just create a channel. After that, we are just creating one more function that is called RPC Observer. And this one, it will going to observe the activities, like if you are sending something from the client, then we will process some operation inside this RPC Observer, and we will just respond accordingly. And this is the RPC request, which is we are going to use while we will just send some kind of request to other services. All right, this is exactly this AMQP leaf. This is which is already we have installed right here as a kind of dependency. All right, so let's add some code right here in get channel. Here, first we are checking this AMQP leaf connection is null or not. If it is null, then we are just creating a connection from here. So about this string, like connection string, I'm just using my local machine RabbitMQ because I have already installed in my machine. So if you wish to install this one, then you can go to the RabbitMQ website, and with the help of the brew, you can install it right like this way. First of all, you need to update your brew, and you can just install brew, install RabbitMQ. Okay, and make sure like you are exporting the path as well as, then that is the way you can get the version as well as. In my case, like, so in my case, I have already installed RabbitMQ, so I can just start RabbitMQ by doing this way, brew, yeah, then start. So it will gonna take a little bit time. So already it's been started with me, so no need to start again. All right, it's already been started. So to stop again, you need to do like brew service stop RabbitMQ. That's you can do. If you don't want to use your local machine version, then you can just go to the cloud RabbitMQ portal, like cloudamqp.com, and you can click on the get start and you can register, and then then you can use it. All right, so in my case, I have already registered, so click on the login, then I'm just filling up my login information and click on login. So once you logged in, then you can see this kind of portal, right? So here you need to create a kind of new instance. So click on the new instance, and you just put your information right here. Once your instance is spin up perfectly, then you just click here in the test instance, then you will get the this is the URL exactly it's going to be needed, right? So you can click on the password and you will get the password, and you can click here, then whole thing you can just click on the copy from here. Yeah, it's copied, and go to your source code right here, and instead of this one, you just paste it right here. So yeah, that's done simply. So in my case, I'm gonna use the localhost because I don't want to use the cloud one, right? And right now, what is happening right here? We're just creating a kind of connections from here, and once this connection has been established or this has been assigned, then we're just creating a channel from here. And while we are just calling this get channel, then every time it will give a kind of new channel, right? So that's the thing. All right. So now let's move forward to the RPC observer. So what exactly is observer going to do? Like every time if you have received any kind of the RPC call, then it will monitor the stuff and it will give you back some data. So let's add some data quickly, and after that I will make you understand what exactly going on inside. All right, so in the RPC observer, you can see we are using two parameters. One is a kind of RPC queue name, one is a peg response. So peg response, it is coming from outside, where exactly we will just process some data or something while we will receive certain requests, right? So this peg response we will replace with a kind of some original whatever the database operation or something we are just going to do, or we are going to pass it right here. So just to simplify here, this channel will assert a queue by this queue name, and it is putting as a durable false. It will just not stay forever. Once this is kind of delivered, then it will go away. And after this prefetch, exactly why we kept the prefetch, because the prefetch is a kind of value defines the number of maximum number of the unacknowledged deliveries that are permitted in this channel. In our case, it is 1, right? And second one is the channel consume. This channel will consume any message if it is coming by this queue name, right? If that the message has contained, then we will perform this operation in terms of we will process some kind of the response the database operation here, DB operation till here. All right, so this channel, once this DB operation is done, then we are sending some response in terms of like whatever the response we are getting right here. So here, this peg response will go here, right? Let's say this peg response will go here along with this payload. Okay, so these are the things we are just returning back to the client or whoever exactly making this request. And to whom exactly we are sending this request, where this message will be having a kind of property which is called reply to, that the queue name will come right here. Okay, that queue name. While we will listening to this queue, then we will get a message. At that message, we will check if that message has a reply to queue name, then we will provide this specific data or whatever it is, and we will send it to here. And along with, we are just providing a kind of correlation ID, which is also coming from the message property, which is called correlation ID. Okay, that means this message will deliver to a specific queue and to specific client or specific object or specific call, right? Which is we are just identified by correlation ID. That's good. So now this part is done, and one thing is there. This is called RPC request, right? So this is observer one, and this is the request one. So let's add some code right here in RPC request. Then I'll explain what exactly going on inside here. That's good. So here what we are going to do, like we are just creating a kind of UID. That is a kind of ID which is we are providing to request. That is called correlation ID. We are just creating right here. Every request will be having their unique correlation ID. So you just keep it right here, a correlation ID. Okay, and we are just requesting some data, and this is a kind of helper function. We just made it. Okay, so let's add this quickly. And this is that's going to be the same. Just like this. Okay. And we could have like build a kind of big function, right? But just for understanding, we should have to keep the code minimized in terms of to debug or something. We need to split it up accordingly, like specific. Rather than writing a kind of bigger chunk of a big function, just split it up accordingly. What are the responsibility? What are the logic? You know, it'll be more simplified and more readable. So that's a kind of best practice in JavaScript. I don't know how other people are followed, but in my case, I'm just finding it's a kind of good way. So let's add this request data function. All right. So in this request data function, also we are just getting kind of sender channel. Right now. Okay, this will be basic. Right then. While we are sending any request from here, then we should have to have a kind of unique ID. That's a kind of correlation ID, right? So with the help of UID, we have just created that one, and we will provide the payload and the queue name. So this payload is a kind of request payload, right? That is yours just to try to send it. So that means if you are looking for user profile, then user ID or some information we are just to provide it. So maybe you can rename this one as a kind of request payload. Request payload. That will going to be like more meaningful. That's good. So once this is sent, then go to request data. Here, this one again, I'm gonna rename this one kind of request payload. Then this request payload we will send it to the server or send it to somewhere, right? To whom exactly we will send it to? We will send it to this RPC queue name. Whatever name we will provide, we will send it to this one, right? This request will go to that specific queue. And what we did here, we are just creating a channel, and we have just created a sort of a queue right here, and we're just keeping it as kind of exclusive true. That means if some response or something is going to be come over here, then this specific channel, specific connection only able to receive it, not the other channel. That means because this request data will call from here while we'll just receiving maybe visiting this route or this route, all right? Then certain connection will be going to be open, and certain queue is going to be assert, and it will accept this send this request and consume this response right here. So the send to queue is happening accordingly, like we are sending the request payload and reply to that the queue name we are just providing right here, and the correlation ID we are just providing that UUID which is passed from here. Okay. And now once we send the request, we need to just determine whether we are able to receive the response or not. So to do so, we are just doing this one, right? So here I'm just keeping inside a promise, because as soon as we are receiving this response, we should have to get back to this route as well as, right? Maybe product or customer, whatever it is. From here, we should have to get back. The request part is done. Just let's move forward to the response part. We have already sent the request to some service. All right. Now we are just waiting for the response. So how we can get it? By doing consume. Channel will consume that specific request by this queue, right? And after that, it will determine like if any message we are receiving. If we are receiving any message, then message can have properties, and that properties will be having kind of correlation ID. That ID, specific ID, if it is matched with the UUID, all right, then we will resolving this promise. That means we have received the message, right? And if it is not received, then we will reject the data from here. Okay. So these are the things exactly it's happening, but we should have to expose this stuff in order to use right here. Okay. So in that case, let's expose this stuff. So what we are missing right here, everything is good, going good. Okay, that's perfect. And export here module export and so these are the things exactly we have just provided from here. But why it is saying unused? Maybe this is okay. So this is clubbing with like name. So what you can do, you can just keep it UUID 4. Let's keep it this way. And where we are creating this UUID, yeah, this one. Now it's perfect. Now let's go to customer and the product. So while we are just visiting our profile, then maybe we can just a little bit rename this this profile in terms of like the route. We are just getting like wish list, maybe wish list, right? And maybe here we can just like product, in terms of product, like the customer. Okay, so specific product, we're just looking for a specific customer who exactly rated or something, that is we are going to call it from here. Okay, first of all, let's add some code to the customer here, then we will just add some code in the product. Okay, then customer right here, we are just going to use that RPC Observer, and this observer will be having a kind of queue name, because this belongs to customer. Then what we are going to do, we will put a kind of customer RPC, the queue name. While we will responding from the customer, we will just respond with a kind of pick response, right? That is also we need to provide it right here. Right, so this is our customer response, and we will just put it. Okay, and the same way we will do it here also in product also. So what we're going to do, we'll just put a kind of not customer response, and this will be our response, right? So and this will be our privacy, and we'll do this one, again we go and maybe all right, so our RPC observer is on place. So now let's just spin up the server. So let's see what are the things are going wrong. All right, so you're on start. Okay, all good. So customer is running, but the product is failed, because why? It's saying RPC observer is not defined. That means we have not imported the RPC observer right here. Yeah, that's good. So what are you going to do? Maybe, do we have a quick fix? No. Okay. Const require RPC, and we can import here RPC observer. That's good. Now you can see what these services are running. Perfect. So we will call RPC request from here. First, const request payload, like ID. This is going to be product ID. 1, 2, 3. Okay, and maybe customer ID. Right, so maybe this customer ID. Okay, we're putting it here, and now we're going to call some response data equal await, and here on the RPC request we are just going to call. Then RPC request will be having the parameters, right? Then whom exactly we will try to put this request, right? We will put a kind of request to the product service. All right, the product service will be having kind of RPC the queue name, so that's a kind of product RPC. That is, we will put it here. All right, and second one, we will need to provide the payload. That's a kind of request payload. Just to provide it here. That's good, but we are not marking as a kind of async here. Async, and let's try to like wrap it up with a try catch. Okay. Or error, and this one we will put it inside the try block, and this one we will put it here, and right now the response data will come over here. That's good. And here also, if we receive any kind of error, then what we will put, let's status will be 200, and let's symbol 400, or maybe you can just put it 500. Okay, then the error we can just put it there. That's good. So it's well structured. Only thing is to like just to print it out here. Response data. Okay, that's good. Now let's move forward to the product one. We will do the same thing with product as well as. Let's get the data from here and go to product, and once we go to the customer route, then we will just return something like that this way. Let's put the async, but again we need to have the RPC request as well as put RPC request. Now this payload will be not having that the product ID, so this payload will be having the customer ID, right? The customer ID, let's say. Okay, and response data is perfectly fine, and this is not product RPC because we are sending the request to which queue? To customer queue, right? To customer RPC. So to this queue. Now request payload will go through, and after that we will get the response. So that's all. So once we will receive this stuff, then we will get back on our browser. Now it's a testing time, but before testing, we will do one thing. We will check whether we are doing this stuff from here correctly or not. So this DB operation, maybe we can just put a kind of one more function that is right here. And here, and here we can do this, or that's how you. Something like also log and the payload and also log or payload. So your parameters like okay, and you return the request, and this is like result and result. And you can do other way around. Maybe you can put set timeout and you can just return it. That's up to you. But in my case, I'm just try to do some different way. So here we are just set timeout, and here we are just putting set timeout, and here maybe we can put 3000. Okay, and here return the result. Result will be the peg response. Yeah, so this expensive DB operation, maybe we can just replace with this one. Okay, wait, all right, expensive DB operation, and here we can just put simply payload and peg response. That's good. Now let's spin the server and see how exactly it's working. And start. Okay, now both the server is running. So I'm going to do a little bit resize this window, and in customer service we are going to create a call, that one which is called wishlist, and from the product service we are going to call customer, right? So the product service, we are just requesting customer information from customer service, and the customer, we are just requesting that the product list from the wish list, all right, which is going to call from the product service, right? So this RPC queue is going on, but it seems like it's spinning up, but there's no response. So definitely something is going wrong here. Let's try it out where exactly it went wrong. So we can see observer is perfect for customer, and we have a payload and request also. It seems it's all good. Okay, go to RPC. Now you can see here connection is happening correctly, and this is we have recently added just to get the kind of database fake database operation, right? And yeah, observer, we have channel, we have a sort queue with the queue name, prepass, this is fine. Queue content, message content if have, then if the message has the content, then we are executing this piece of code and we are sending the stuff to the queue. And here property replay, yeah, this is a typo, which is replay, it should have to be replay. Okay. Right now here I think here one more line we need to add, that is going to be like channel egg will be messages, right? So once you're sending the stuff, then once you're receiving the message, you know, then we should have to acknowledge this one. Okay, then we're acknowledging here. The same typo is going to be happen from here as well as maybe yeah, this one also. That's good. And I think it's all perfect. This is a kind of async call, so what we are going to do, we'll put a wait here. I believe now it should have to work. Let's go here. Yeah, you can see this is coming, right? And other window, yeah, this is also coming. So while we are calling from the customer service, right, from the product service, right, then it is just giving the customer information, right, from the product service, this customer one. Okay, and this 9001, it is the customer service, right, which is requesting, which is asking for the product information, and you can see here this is the product ID and this is the product title and price. This is currently it's coming perfectly. All right, so far our both these services are working, and we can request the data from other service with the help of the RPC, right? So but what if, like, if we are calling certain service and this expensive DB operation taking more than the expected time, let's say if it is going to take approximately 15 seconds to execute the whole operation, then in the request side we cannot wait until indefinite time, right? Because we don't know how much time it's going to take to return the data from other service. So to get rid of this issue, we can just we can add it right here, some kind of mechanism like, you know, timeout mechanism. So that is we are going to do here. So let's set a kind of timeout with the n seconds, right? So this timeout we will put it inside the promise, because if it is timeout, then we should have to return the data to our service also, just to notify, like, you know, we are not be able to receive the data or something. It's maximum 10 seconds. We will just wait, and after that we will set the timeout, or maybe we can put a little bit less, maybe 8 seconds, right? And here what we are going to do, we're going to close this channel. We're going to channel close, because the data has been requested to the server or maybe some other service. We have waited enough, right? And after 8 seconds, if it is giving data also, we are not accepting at all, because channel, we are going to close it here. But those data doesn't make sense to me, because client will not wait till beyond this limitation. Okay, now here we will just resolve the promise. Now if the API will be able to fulfill the data on time, then what we are going to happen here, we're going to do clear timeout will be timer. Okay, so this is correct. Okay, that's good. So now let's go to request data somewhere. In this one, we're keeping it like around 3 seconds again, right? Now we're looking for our data. Let's go back here. Server is running now. With this 1, 2, 3, yeah, we are able to receive the data, right? Now extend a bit, little bit time. Let's say I'm gonna put it 9 seconds. Okay, which is a little bit greater than our timeout. Then what exactly it will return? It will return the API couldn't fulfill the request. Okay. So now let's once again, and I'll like wish list. Now let's check. Okay, right, yeah, can you see it is giving the response, API couldn't fulfill the request. That's wonderful. So this is the way exactly we are handling the request timeout also in RPC calls. I'm just to try to make it very simple, so you people can implement, can understand exactly what exactly is happening behind the scene. Just to recap what we did here, we have just created 2 simple Express app as a service. Okay, in that service we are exposing 2 routes. One is the kind of wish list, where customer will be calling the wish list items from the product, and the product will be calling customer informations from the customer service. So these are the data exactly. Customer data is not belongs to product, and the product data which is not belongs to customer. So only product is responsible to return the product informations with the help of the RPC request, where we are just triggering, or we are just calling that RPC request from here and sending the payload, and it is returning back with a certain data. Okay, so this is exactly it's happening right here. And in the RPC you can see, first of all, we are just like using 2 libraries. One is the AMQ believe, and second one is the UUID. Okay, so here we are just creating connection, we are getting the channel, and after that we are just creating one observer which is going to observe our RPC request if it is coming from outside, and it will gonna resolve this stuff. So here you can put your DB operations or whatever based on what data it is exactly looking for, in terms of like message as content, or message we can put some kind of payload type also. Depends on the type, you can perform your operation here and get the data and send the data back to the client. Okay, and this is the request exactly which is happening. We are just sending a request to other service, where we need to mention the request queue name which is exactly intended to, and you should have to provide the request payload here, and you need to mention the queue name and correlation ID, which is a kind of UUID we have used here. And after that, once we receive the data, then we are just returning this data to as a kind of promise, because we should have to serve the routes also here, right? This response data we are just returning back. So I hope you people have understood like how exactly the RPC communication is happening. So this is the same thing we are going to apply in our application here, right? So what we did exactly in our existing application, we have the right access through publisher and subscriber. Right now today we have just covered this one, and next episode what we are going to do, we are going to implement in our microservices the same pattern, right? And because already it is there, so we just a little bit copy paste code from here, and we can just implement the same thing right there. So the last thing is to let's understand the communications. So as you can see, we have like customer and product service, body service, and we don't have the direct access to each other. With the help of like RPC, we can have a direct access, but how? With the help of RPCQ. That's straightforward. And now you can see that we don't have any redundant data here. So if we are keeping any data reference from the product, then we are going to query the data from to RPC. Then product service will responsible to get the data, just like this, what we did here, right? This observer, it will just to give the data accordingly. So I hope you people have enjoyed this video tutorial, and there are much more other stuff also there, which is we are going to cover, like, you know, segregation of our own responsibility, and in terms of like removing the unwanted data and just keeping the data to the close to the service. So those are the things we are going to cover in upcoming tutorials. Thank you very much for your valuable time, and I hope you have enjoyed this video tutorial. And if you have not subscribed my channel, you just subscribe my channel, and just if you really like this tutorial, just to put a thumbs up, because it will give me motivation to make more videos and contribute more knowledge. And as you can see, we have a couple of more interesting topics is coming ahead, so it will be wonderful to see you right there in future tutorials also. Thank you very much, and have a wonderful day.